Hello learners, I welcome you all to this video program on Ocean Floor and Relief Features Part 2. In the previous part of this program, that is Part 1 of Ocean Floor and Relief Features, we studied about different techniques employed in measuring the depths of the oceans like echo sounding technique and satellite altimeters, how they map the bottom or ocean floor. We had studied about that, and we also studied about hypsographic or hypsometric curve, which is a representation of different relief features in the lithosphere and hydrosphere with respect to the sea level, and it is represented in the form of cumulative height frequency curve. Although it does not represent the exact location of the relief features, but it is a relative representation of all the features with respect to the sea level. And we also studied about different relief features of the ocean floor. You came to know that just like continents, ocean floor also has relief features, and they are from starting from the continental shelf, which is a continuity of the continents and is having a lesser slope, like ranging between 1 to 3 degrees, and then we come to the steeper continental slope, which is having a greater slope of about 5 to 60 degrees, and then comes the huge depositional zone, which is called the continental rise at the bottom of the continental slope area, where it merges with the deep sea plain. And then comes the deep sea plain, which is the extensive flat plain with few relief features like mid-oceanic ridges and sea mounts, guyot. And then we also studied about oceanic trenches, which are deep narrow valleys with very steep slopes, and they are the deepest part of the oceans. So in this video program, we will study about the different relief features of some of the major oceans of the world, like Atlantic Ocean, Indian Ocean and Pacific Ocean. So we are getting into more detailed study of the oceans and their relief features. And after viewing this video program, you can also compare the bottom reliefs of the different oceans of the world. The major oceans we are covering in this are Atlantic Ocean, Indian Ocean and Pacific Ocean. Now let us start with the bottom reliefs of the Atlantic Ocean. Now, short introduction to all oceans we have already done in the video program on Introduction to Hydrosphere Part 1, where we studied about all the major oceans of the world. Still, I am just giving a brief introduction. Like, the word Atlantic came from the Greek word which means Sea of Atlas. It is located between North and South Americas in the west and Europe in the east. It covers an area of about 82 million square kilometers. It covers 1/6 of the geographical area of the globe and half of the area of the Pacific Ocean. The ocean is S-shaped. You must have studied in the block on lithosphere in the chapter dealing with plate tectonics, how the land masses happen to be united in the form of Pangaea, and and how the North and South American portion of this Pangaea shifted towards the west, and it led to the origin of Atlantic Ocean in the middle. This S shape also suggests that continents or land masses on both sides once form a contiguous part, so they can jigsaw fit. You must have studied in the continental drift theory of Wegener, the famous jigsaw fit of Wegener, in which the continents on the left of the Atlantic Ocean roughly fits into the eastern part of the Atlantic Ocean. Now there are several marginal seas in the Atlantic Ocean like Mediterranean Sea, Weddell Sea, Nordic Sea, Hudson Bay, Davis Strait. We have covered these portions in previously also. Coming on to continental shelf of the Atlantic Ocean, its width varies between 2 kilometer to 80 kilometers, and it at few places it even exceeds 400 kilometers. So extensive shelves are found around Newfoundland, Greenland, Iceland, and between Bahia Blanca to Antarctica. Continental shelves are narrow along the coasts where mountains are found in vicinity. For example, the African coasts between the Bay of Biscay and Cape of Good Hope, and the Brazilian shelves. Important islands include Azores, Ascension, Tristan d'Acunha, Falkland Islands, Shetland Islands, St. Helena, etc. Now coming on to mid-oceanic ridge of the Atlantic Ocean. It is one of the most important feature and needs to be discussed in detail. It extends from Iceland in the north to Bouvet Island in the south, covering a total length of about 14,450 kilometers, and it is known as Dolphin Rise in the north and Challenger Rise to the south of equator. It is also known as Vivelet Thompson Ridge between Iceland and Scotland. It is called Telegraphic Plateau to the south of Greenland and Iceland at about 55° north latitude. This is because the first telegraphic cables were laid at this place, and there are a number of branches running from this mid-oceanic ridge to the east and to the west, dividing the Atlantic into several basins. Now these are the branch ridges, I will name them, and then we can look for these ridges in the figure. One is Newfoundland Rise, Azores Ridge, Sierra Leone Rise, Para Rise, Guinea Rise, Walvis Ridge, and Rio Grande Rise. Now you must have noted that at some places I am calling rise and some places I am calling ridge. So what is the difference between them? The formation of both ridges and rise are similar, like they are both associated with the diverging plates, but the difference is only that the ridges are having greater height compared to the rise. And so mid-oceanic rise or ridges are similar in origin, and continental rise happens as we have mentioned earlier also. It happens to be a huge depositional zone just at the bottom of the continental slope where it merges with the deep sea plain. So you should differentiate between continental rise, mid-oceanic ridge, and mid-oceanic rise. Now you can see in this figure on the bottom reliefs of Atlantic Ocean there are several ridges, as I have mentioned, the Newfoundland Ridge, Para Rise, Rio Grande Rise, all can be seen in this figure. And the mid-oceanic ridge is the S-shaped, which is shown in the central white part of the Atlantic Ocean, and the continents on both sides are also named. So you can go through these figures in detail, and you can also search for some figures in the internet and find, if you happen to come across some good figures or good maps, then you can locate all the ridges and all the basins. Now coming on to basins of Atlantic Ocean. The mid-Atlantic ridge divides the Atlantic Ocean into two major basins, that is the eastern and the western Atlantic basin. In the west there are four major basins like Labrador Basin and North American Basin, Brazilian Basin and Argentina Basin. So since the mid-oceanic ridge divides the Atlantic Ocean into two major basins, the branch ridges which arise from the mid-oceanic ridge divides it into further sub-basins. So western part is having four basins, which I have already told just now, and the eastern part is having basins like Spanish Basin, Canary Basin, Cape Verde Basin, Guinea Basin, Angola Basin, Cape Basin, Agulhas Basin and North Indian Antarctic Basin. So you can see most of these basins or ridges are named on the basis of their location or the places where they happen to go. Like ridges are moving somewhere in the northeast direction towards Newfoundland, so it is called Newfoundland Ridge. So in this way you can see in the description part also in your books, even if you don't find the ridges or basins mentioned in the figure, you can just visualize where they are located on the basis of description given in your course materials. And the course materials are easily available and can be downloaded from the eGyan Kosh under BSc General Program CBCS and Physical Geography. Now coming on to Atlantic deeps, Murray has reported around 19 deeps in the Atlantic Ocean, but they are located only at depths below 5,000 meters. So some of the important deeps are Neas Deep, Puerto Rico Deep, Romancha Deep. So not too many deeps are found in the Atlantic Ocean compared to the other oceans like Pacific Ocean. Now we come to the bottom reliefs of Indian Ocean. As we have already mentioned, it is one of the youngest oceans and the very complex because the northern part is eastern and western parts are blocked by continents. So it is having 3 distinct regional zones. First one is the western zone, which includes the area between the mid-oceanic ridge and the African coast. The second one is the eastern zone, which is relatively deeper, and third one includes the elevated portions near the mid-oceanic ridge and includes several island groups. Now continental shelf of the Indian Ocean is more extensive and along the margins of Arabian Sea and Bay of Bengal. It is of the order of 600 kilometers wide in this area, and along the eastern coast of Africa around Madagascar also huge extensive continental shelves are found. Now they are narrow along the coast of Java, Sumatra and along Australia as well as northern coast of Antarctica. Now coming on to the most important part, that is the mid-oceanic ridge of the Indian Ocean. It is about 9,000 kilometers long, so it is shorter compared to the Atlantic Ocean, and since the northern part is blocked by continents, so it is not touching the two ends of the meridian like it happened to be in the Atlantic Ocean. The ridge is relatively wider and is not sharply turned into S shape like the way it used to be in Atlantic Ocean. It is divided in the southern part. This is an important feature in Indian Ocean, that the ridge is divided in the southern part. The northern part above the equator is called Lakadiv-Chagos Ridge. Then Chagos-St. Paul's Ridge between 0 to 30 degrees south latitude, and it is called Amsterdam-St. Paul's Plateau between 30 to 50 degrees south latitudes, and after that it bifurcates into two. The western part is called the Kerguelen-Gosberg Ridge and the eastern part is called the Indian Antarctic Ridge. Now there are similar to the Atlantic Ocean, there are several branch ridges from the main central ridge, and they are like it's given in the slide: Socotra-Chagos Ridge, Seychelles Mauritius Ridge, Madagascar Ridge, Prince Edward Crozet Ridge, Cape Price, Andaman and Nicobar Ridge, Carlsberg Ridge, Murray Ridge. You must locate these ridges in the figure over here, and if you don't find most of the ridges in the figure, don't get disappointed. Like I told you earlier, you can go through the description of the ridges and you can see that most of the ridges are named on the basis of their locations, like some are located in the vicinity of some islands, so it is named on the basis of that island's name. You can see in this figure, Chagos Lakadiv Ridge forms the central ridge of the Indian Ocean, and then you can see the lighter portions in the ocean, which is marked in light blue. They are also the ridges, and you can see the southern part the ridge bifurcates into two. Here it's written Southwest Indian Ridge and Southeast Indian Ridge. So the two ridges which I mentioned there, like the ridge is divided into two, and then you have one Andaman Ridge, which is also called 90° East Ridge, because it is parallel to the 90° East meridian. So you can see that also, and then below it you can see the Broken Ridge and so many other ridges like Carlsberg Ridge. It's not located in this, but based on the description you can visualize where it's located. Like it says, it divides the Arabian Sea into two parts. So it is found in the mid of the Arabian Sea. So similarly, you can see that the basins, there are the central ridge divides the Indian Ocean basin into two major basins, western and eastern basins, and then branch ridges also divide it into several sub basins. Like on the western side you see we have Oman basin, Arabian basin, Somali basin, Mauritius basin, Natal basin, Agulhas basin. The basins are found at depths ranging between 2000 to 4000 meters, and at some places in the southern basins have average depth around 5000 to 7000 meters also. The eastern basins include Andaman Basin, Cocos Keeling Basin, Atlantic Indian and Antarctic Basin, Atlantic Indian Antarctic Basin, Eastern Indian Antarctic Basin. So you can locate some of the basins here, and some of the basins on the basis of description given in the text. You can see, you can visualize where they are located. Now coming on to deeps of Indian Ocean, there is only one major deep in the Indian Ocean, that is Sunda Deep, or located in the Java Trench. It is situated along the Fold Mountains south of Java Island of Indonesia. You can see in this figure on the bottom reliefs of Indian Ocean, Java Trench is located just below the Java Island. Now we study the bottom reliefs of the Pacific Ocean, but before we come to the relief features, just it is important to know that the ocean is studded with huge groups of islands. Some are large continental islands like Aleutian Islands, British Columbian Islands, Chilean Islands. We call these continental islands because the geomorphology is similar to the adjoining continents, but due to some tectonic activity it has separated from the continents. And island arcs and festoons like Kurile Arc, Japanese archipelago, Philippines Arc, Indonesian Arc. Like in the previous part of this video program, we studied how these island arcs have been formed along the subduction zones. The denser plate gets subducted beneath the lighter plate, and then it melts, and then the molten magma penetrates through the fractures at this and these form volcanic islands. So these form also trenches are formed over this subduction zone, and when the molten material penetrates through the fractures, they come up in the form of volcanoes, and so these form island arcs and festoons. There are several small scattered islands also in the Pacific Ocean. Some are classified on the basis of races like Melanesia, Micronesia, Polynesia. Some are classified on the basis of their volcanic origin or activity like Hawaii Islands, and some are coral islands like Ellis, Fiji, Funafuti, etc. Now coming on to continental shelf of the Pacific Ocean, it is quite extensive in the western portion along the Japanese Indonesian archipelago and along the eastern coast of Australia. And the eastern Pacific is relatively narrow where the average width is only about 80 kilometers and at few places it is only 45 kilometers wide. Now one special feature of the ridges regarding the ridges of the Pacific Ocean is that this ocean is devoid of any central ridge. So we see one of the most important ridge and the huge one is the East Pacific Ridge, which is also called the Albatross Plateau, and I will show you one figure which is the satellite imagery of the East Pacific Ridge, and you can see the lighter portion in the Pacific Ocean stretching from California then throughout the ocean and then coming on to New Zealand area. This is the entire portion is the East Pacific Ridge. This is an open source image. It was in public domain and it was taken by Itopo 2 and from NOAA, NGDC. NOAA is National Oceanic and Atmospheric Administration and NGDC is National Geophysical Data Center. So this figure was in public domain and here some of the features are quite invisible, so I got this figure for you. Let us come to other ridges which are also important, like Cocos Ridge, which further bifurcates into two parts, the eastern part is called Felix Juan Fernandez Ridge and the western part is called the Southeastern Pacific Plateau. There are other ridges like Hawaiian Ridge, Marcus Necker Ridge, Chatham Ridge. Hawaiian Ridge you can see in this figure, it is located near the Hawaiian Islands. You can see in the central part of the Pacific Ocean, Hawaiian Ridge is shown. And you can see in this figure that there are several fracture zones also in the Pacific, which are very clearly marked in this figure. And apart from ridges, now coming on to basins, the basins or depressions are found all over the ocean. Since the ocean is devoid of any central ridge, so it is not divided into western and eastern like we had in other former two oceans we have discussed, the Atlantic Ocean and the Indian Ocean. So the important basins are Philippine Basin, Fiji Basin, Aleutian Basin, West Caroline Basin and East Caroline Basin. So you can see most of the basins are named on the basis of their locations. All these basins range between 4,000 meters to 6,000 meters depth. You can see some of the basins located in this figure on the bottom reliefs of Pacific Ocean. There are 32 important deeps or trenches located in the Pacific Ocean, and you can see in the table here like Mariana Trench and the deepest point of all oceans of the world is the Challenger Deep, which happens to be in the Mariana Trench, and it is 11,022 meters deep. Then we have Tonga Deep, Kurile Deep, Philippines Deep, Japan, Kermadec. Some of the deeps you can locate in this figure on the bottom reliefs of the Pacific Ocean. So in this video program we studied in detail the bottom reliefs of all the three major oceans of the world, like the Pacific Ocean, Atlantic Ocean and Indian Ocean. In the next video program we will study about distribution of temperature in the oceans. Thank you.